This is Dan Abbott. This is my third video in the series on AutoLISP programming for the AEDD260 CAD management class at Southern Maine Community College, and take a look at a few other elements of Lisp programming. Back at the PowerPoint, turned into a PDF file. One of the things I wanted to point out was the use of transparent commands that you can create within AutoLISP, in the sense that they can be used to do some calculations. And one of the things that sometimes comes up is you end up with a metric value that you're using in a drawing that is not a metric drawing, and you want to convert it. You can do that easily enough by going to your calculator and doing the conversion. But the version of the conversion program that we wrote, the one that looks like this, where it actually tells you what it is helpful. But it'd be kind of nice if you were doing something like this, where you're drawing a line and you knew you had a specific angle, you had a direction, and you've got polar tracking set up for that. And you want to be able to type in a value that you know in inches, and you want it to be converted into millimeters. And so the function for doing that wouldn't give you an alert box. It would just do the basic math for you. So I'm going to show you how you can use this as a transparent command. So I'll open up VLisp and we'll put a little header. This is just a development file right now, so I don't really care about the header material at the top. I'm really just trying to work things out. So these notes are really for me. I'm just going to indicate that I want this to be a transparent command for converting metric and inches. Alright, so I'm going to define a new function, but this one will not act as an AutoCAD command directly. In other words, not going to have the C. Instead, we're just going to call it, I'll call this II because it's easy to type. And then I'll put as an argument IN. So what's going to be is this. I'm going to have a function called II, and if I feed to it inches, I want it to do this. I want it to multiply. That's the function, so that has to start. Whatever we type in here, that's the argument, by 25.4, and that's going to be the whole program now. And I'm going to load that program right here. So now if I were to say I want to go something here, and I know what it is, and I'm going from inches to millimeters. So actually what I need is a metric drawing. This is a case where I know something in inches, but I want to convert it to metric. So let me start a metric drawing on that. So I'm going to go back over here. I'm going to load this again in this drawing. So let's say I'm taking a line, and I want to draw that line at an angle of 30 degrees, and I know that I want the line to be 190 inches. No, let me say it's just smaller. Let's say 25 inches. And so if I put in a parenthesis, II and 25, and then do that, it'll draw a line for me by converting it from inches into millimeters. So if I then check and see what's the length of this line, it's not 25 inches, it is 635 millimeters instead. Let me just do that again. So again, let's say I know my height. Let's say I know 72 inches. 74 inches. And I want to convert that into millimeters because I'm drawing a line here. Again, if I type the parenthesis, the II, and then the 74, it'll take that inches and convert it into millimeters. Now, what is that in millimeters? (1,879 millimeters). If I wanted to do it in meters, I could do the same thing. I just have to divide by a number. That was the metric, the meter equivalent of it. And we go the other way as well. So in other words, I could also have a function defined as mm, and say we're going to have mm as the argument for it. Now in this case, we're going to say and divide mm by 25.4, and that'll convert it back to inches. So now if we load that function, let me go back to my drawing that's in inches. So if we load that function, I don't have my tabs turned on. Thought I did. Okay, so this drawing is in inches. It's actually in feet in inches. But now I'm going to load that program in. And let's say for some reason I know the size of something in millimeters. So I want to go at an angle like this, open parenthesis, and I'll type in mm and say convert, say 400 millimeters into inches. I do that, and it does the conversion for me. 400 millimeters to convert it into inches is 1 foot 3 3/4 inches. So it does that conversion. So it's just a way to deal with a transparent command. One thing about this, though, in order for that to work, I don't believe there's any way. Let me try something. You have to actually use polar tracking is what I'm going to say, because I think if we said I want to draw a line at, and then I do this, let me try that. At mm, no, that's not going to work. So what I'm going to have to do here is, in order to use it transparently, you really have to be in a line where you're drawing at a specific angle. So you set your polar tracking angle to a logical increment, and if you're drawing along those increments, then this thing would work. Because what you're going to have to do in this case is put in mm, then a space, do it at the command line. And again, if it's 1,000 millimeters, you do that, it automatically converts it into inches. 1,000 millimeters converted into inches is going to be about, about 38 inches. Yeah, about 30, 36, 37, 39, almost 40 inches. So, okay. Now, that's one thing. Let's just get rid of this now. We'll go back to the PowerPoint now. So the other thing I wanted to talk about today, not just transparent commands, but I want to go back and deal with a well, this is probably worth making a point about. A couple of you have done some things where you wanted to have something happen when you first started AutoCAD. So there is a function called the S::startup function. And if you place that in your ACAD.LSP file, the one that loads automatically in every drawing, if you start by defining that function, and this, don't worry too much about what this means, but just define it with defun-q instead of just defun, you can go in, for instance, and undefine existing commands automatically when you first start the software. You probably wouldn't want to do that for a line, because a line command is something that you use a lot. And in this case, what I've done is undefined it on startup and then had a little alert saying the line command will draw polylines on layer object now. And so if you want to use the line command the way it's meant to be used, you have to type a period instead. And all this code is going to be converted into an alert box. Now when you come down here, you redefine line to do the things that it says up here. So the undefined function can be something that you fire off when you first start up every drawing. Now you can also put other things there as well, Lisp code that makes whatever other changes you want to make. Not very often that you're likely to do that. I do really like having a circle command that uses D instead of R, so I sometimes will redefine that just for the heck of it. That's, yeah. So, now let me see what I want to talk about next. Okay, it's the angle functions. Okay, so we started, I mentioned this last time in my last video. I indicated that computers use radians instead of degrees when they deal with angles, and there are times when that causes a problem. So what I wanted to do was to talk a little more about that, and then I want to go through the process of just taking an existing program and making it better by adding things to it, and just go through and show you what that would look like. It's going to take a little while, but we're going to concentrate on two programs today, and then I'll be doing some additional videos as we go on. Just a reminder, a radian is a number that is much smaller than the same number in degrees. 1 radian, and this is 1 radian right here, is the angle that you get between two lines drawn from a common vertex that are essentially radiuses of a circle. And if they have, the length of the radius is the same as the arc length of the section of the circle that they encompass. That gives you an angle of 57.296 and a bunch of other numbers. And that is 1 radian. And If you take a look over here, 90 degrees going straight up is pi divided by 2 radians. Now this seems odd. It just happens that computers find it much faster to calculate with those. But the problem is that there are times when you're writing a Lisp program when you're asking the user for an angle. And the user is likely to type in an angle in degrees and not radians, but the computer internally often wants to use an angle that is measured in radians. So there are times when you have to convert between the two, and there are some conversions that you would do. In most programs, most people who have an ACAD doc LSP file have these two functions that they define for converting between radians and degrees and radians, and they're just always loaded so that any other program they write can use them. So this is what they look like. And when you create them without a C colon. So you have defun, just like the one I just showed you with the inches and millimeters where you're going to use it transparently. As functions, they're not meant to be commands. They're meant to be functions that can be used inside parentheses as a part of a Lisp program. So what we have here is the way to convert between radians and degrees. And so the function defined here doesn't have a C colon, it's just RTD, but it has an argument. And the argument gets put here as a letter that gets reflected down here. And what that's saying is if you issue that function followed by whatever you put into R, it will do the following. It'll take that value, and it has to be a number in this case, and it'll multiply 180 times the result of dividing that number by pi, which means it'll convert from radians into degrees. Going the other way, degrees to radians, you do the same thing. We have a function, DTR in this case, no C. There's an argument, and I just use D, but you can put anything you want in here, as long as what you put in here is the same thing that shows up down here. In this case, going from degrees to radians, you're going to multiply pi times the result of dividing the value in degrees by 180. Note that there is a period here, and there's a period here just to make sure there's no question that that's a real number. So when that division happens, you don't end up happening to get an integer because you gave two integers and not a real number. Now there's a program that I wrote called rotate copy, and I wrote that because there was no way of rotating and copying at the same time at one time. But it's an interesting program because it demonstrates something. So what I'm going to do is I'm going to show you this program set up to rotate a copy of something at a specific angle and show you the problem with not being able to convert between radians and degrees. First, I'm going to go and open up the code that is in that's not what I wanted. The code that is in your book. So I go to the student drive, go to our folder, 260, and go to Lisp. There's a website code folder. And when I published the book, the publisher had a website for it where you could go and download all the code in the book if you wanted to. So if I open 08, and I say what I'd like to do is to open up a Lisp program, so I'm going to go to All Files. AutoCAD Secrets Chapter 8, this opens up all the code in Chapter 8. So if I get down through all those examples that are in there here, there's one we're going to work on now called, well not right now, but we're going to work on that. I'll open that later. But the mid program is here, the SSECT program that creates a structural section with an X that goes down through it is in here. And then we've got this thing called RC, and I called it RC broken. And I am going to right click on this and copy it. It also has the RTD and the DTR functions there as well. What I'm going to do is go over to AutoCAD, VLisp, and I'm just going to paste that code right here. And actually, let me just go ahead and get the header material so that we don't lose track of what we're doing. So I'll put the header material above this, which looks just like that. Now these, I'm also going to go and get the RTD and the DTR code as well, and I'll paste those in here. This is again just a sort of a testing or development file. So here we have RTD and here we have DTR. What I'm going to do up here is I'm going to run this program, and I'm going to show you what I thought when I wrote it. I mean, it's a purposely broke this, but let me just show you how it works and what I thought when I wrote it would happen, and then what actually happens and how we have to correct it. So we'll go and get AutoCAD open here. So let's just, I'm going to just put something here, just a line of some kind. So I'm going to come over here. I'm going to load this program. And then we'll take a look at what it's supposed to do. It's called RC broken. It's got no arguments. Arguments would go before the front slash. So these are actually variables. They're called global variables. And when you're first running a program, it's not a bad idea to just leave that empty until it's all done. You know it works. Then you can go and put all the variables that you've created into that location. And all that means is that whatever values they have, they'll be stripped of those values when the program finishes, and they'll be returned to nil, is what that's called, so that if you use the same variable name in the next file won't accidentally pull values out of something the last time you used it. So rotate copy is what this means. In the first place, we've got this function called setQ, which you've seen, which sets a variable equal to something. And we also are using something called ssget. ssget, when you run it all by itself, closed in parentheses, is a selection function. And over here you get a prompt, select objects, and it'll let you select objects the way AutoCAD always lets you select objects. You just keep selecting till you're done, and when you're done, you press enter. Now, nothing happens with those. They get selected. They create what's called a selection set, and you can see that in the Visual Console. But if you're going to use it for something, you really have to set whatever you pick equal to a variable. Now here's a case where people sometimes get confused. You think variables have to have numerical values. A variable in an AutoLISP program can be set equal to anything. Entities, words, text, numbers, anything. So I'm going to use SS1, selection set 1. I'll load the entire line, and when I load that line, I'll go and I'll pick whatever I want. Well, just to make a point that you can pick more than one thing, let me put something else in here. So what I want to do is rotate those two lines some angle while making a copy of it. So now I'll load this up. When it asks me to select the objects, I'll take both of them. Now I'll come down here and I'll load that line, and it's asking me to create or to pick the base point for the rotation. So I'm going to say I'm going to rotate it right here. Now that PT1 is a variable that maintains or saves the location that I just selected. Now I'm going to come down here and I'm going to get an angle because it's a get angle function. So I'm going to say right here, I want to get the angle of rotation. Now when it asks you in a get function for something, you can pick 2 points and let AutoCAD determine from those 2 points what the angle is. Or you can type it in. So let's just say I want to rotate those things 30 degrees. I come back over here. I've saved what I just typed, ANG1, in response to that question. And I typed 30 degrees because that's what I want. So I saved it as a variable. Now I've got a command. First thing it's going to do is go and use command by itself. And command by itself simply cancels any command you might currently be in, which means if I run this and you're in the middle of a command, it'll first cancel that command. Then I'm going to go to the copy function, and again, period and underscore aren't necessary. The period means if I've redefined or undefined copy, it still works, and underscore means even if I'm in a French language version or some other version of the software, it'll still recognize that as the copy command. So I'm going to say I'm going to copy what SS1. What's SS1? The things that I picked up here. I have to press enter because with AutoCAD, when you're making a selection, when you're done selecting, you press enter to get out of the selection set. I had to do that to get out of this selection set. This one, though, uses whatever I picked here as its selection set, but I could add other selection sets as well, so I have to put the enter to say I'm done picking things. Point 1 and point 1, PT1, PT1. What I'm doing is copying from the point that I picked to the point that I picked, which means I'll end up with a copy of everything I just selected directly on top of themselves. Then I go down to the next command. And by the way, the next command down here for rotate, by the way, nothing, I'll show you in a second. So what are we going to rotate? SS1, the original selection set. And now I'm done selecting that. I have to press enter.
My base points are going to be 0.1. My angle is the 30 degrees that I typed in. So I'm going to highlight this. I'm going to load it. I'm going to come over here and I'm going to type RC underscore broken. And I'm going to say, yeah, let's grab those things right there. There's my rotation, and I want to go 30 degrees, and I do that, and it does what I just asked it to do. The problem is, I wanted it to go 30 degrees, but it read what I typed in as 30 radians, because get angle, when it does get a value, either by picking 2 points or by you typing it in, it gets that value in radians. Well, 30 radians is a big number, but you think about it, 1 radian is almost 60 degrees. 30 radians means it spins around and around and around until finally it runs out of full circles, and then it goes to wherever it lands. In this particular case, it means that's a really small amount. Now, I want to fix this now. And the way I want to fix it is I want to convert radians into degrees. So if I look back, here's my fixed version here. Let me go and highlight that and copy it over for you. Alright, so here's my fixed version. In my fixed version, I do all the same things. But then I do this radians to degrees, because it thinks we've got radians, so we want to convert it to degrees, because we're going to issue degrees down here. So instead of just the ang1 being get angle, ang1 now has another function in front of get angle that is RTD. Well, that's this function down here. In order for that function to be recognized, this function has to be loaded. So if I just did this, and I loaded that without loading the function here, I'll undo that back, and then I go and issue this command, which is a different name than the other one. I say, let's pick these things right here. Here's my base point. Angle of rotation is 30. Oops, error, no function definition for RTD. So this program won't work unless these programs, those functions, have been loaded. What that means is you put these in your ACAD.LSP file someplace. Doesn't matter where. I usually put them at the beginning. So that every time you load that, those 2 functions are available to any other program within your ACAD.LSP file. So now, since we're looking for RTD, I'm going to load that function. Now, nothing's going to happen except that it tells me the name of that function. But now, either at the command prompt or in the Lisp console or in a Lisp program, if I say RTD and I include with that the argument of, this is radians, so let's just say I want to go from 1, and I do this, RTD1 is going to return 57.2958, because that's the number of degrees. Now that's to 4 decimal places. If I wanted to more decimal places than that, what I could do is say I want to convert a real number into a string, and the real number is the conversion of 1 radian into degrees, and I want it to be in decimal form, and I want 15 decimal places. If I do that, now that is as much as you need, 15 decimal places. That's the equivalent in degrees for 1 radian. So now that we know that program, that function works. Now I go back here and run my program, and this program uses that function. Now when I say ROCO, say I want to rotate and copy those things right there around this point, I want to go 30 degrees, bang, I now have a copy of those things at an angle of 30 degrees. If we were in a classroom right now, or if I were in a Zoom meeting, I'd say, does that make sense? And I'd go around the room and I'd ask you if there's anything about that you don't understand. So what I'm going to say right now is, go back and look at it again, look at what we have here, and see if that makes sense. Again, the double right here after the command prompt is simply a way of canceling any command that you might be in. The same thing happened here. It canceled the copy command. Now I'm going to take this and I want to apply that to another program that we looked at earlier. So I'm going to delete all of these things. And the other program that we looked at earlier was the SSECT, the structural section program that would automatically draw a rectangle and a couple of lines across it. And I used that as a specific example of how to create
how to create points from data that you've entered. So if you put a point in, you can pull the x value out of the point and the y value out of another point, and you can put them together. So let's start with that program itself, which is right here. All right, I'm just copying it off from something over here, and what I'm going to do is start making some changes to it. So here's the program as it currently exists. Works pretty well. Come back up here and load it. I come over here and say I want a structural section. This is where do you want to put it? And I'll say, well, I want to put it right here. And the diagonal corner of the rectangle at 5.5, comma 1.5, because I want to put that symbol in here. Now I try it and it does this. I'm like, well, no, I wanted it to go over here. So the first thing we need to do to improve this program is to recognize that if we've got running object snaps on, those running object snaps will override any kind of point we indicate. Because the next point I indicated was right here, but I have a running object snap set for endpoint. So what happened is it went back to that end right there when I put that point in. As a result, this was able to be drawn because that point's not so close to this one that it went to the endpoint of the line. But what I end up here with is a triangle and not a rectangle. Now, what do I do about that? Well, I have to turn off object snaps. If I'm going to turn off object snaps, so before I do anything else, I need to go in and say I'm going to create a variable. I call mine OS. And I'm going to make sure that I know what does this person have set currently for Oz mode. And now I'm going to say, now that I know that and can return that at the end, we'll do a setVar Oz mode. Don't get setVar and setQ confused, by the way. They sound kind of like the same, but they have two different meanings. setQ, I think of as set equal to. That's how you define variables. SetVar means setting a variable in AutoCAD. That's a variable that already exists. setQ deals with variables you invent, or you come up with. setVar deals with variables that are already predefined and part of AutoCAD itself. So we're going to set it to 0 just so it turns them off, and you've seen that before. But if we do that, you got to make sure at the end you go back in and you do a setVar Oz mode back to whatever was captured up here as part of OS. So right now my Oz mode setting is 6183, and I'm going to set it to 0 up here, but I want it to be set back to that down here. Now this also brings up the need for error trapping, because if something goes wrong in this program halfway down through it, I want to make darn sure that it gets put back. Now, in fact, this is probably not the best place to put that. In fact, it is not the best place to put it. I'll find out at the beginning of the program what it's set for, but the place where this is a problem is when all this rectangle drawing was being done. So that's where I want Oz mode of 0 to be. And you really want to put that variable as close as possible to the end of your program. So you only convert it to 0 when you need it to be 0, and then you go back to what it was as soon as you can. Now I still want error protection in this one, or error trapping, but I'm going to put that off until I build a few more things into this. Now if I come down here, load this program again, come over here and run it. First corner is right here. Do the same thing I did before at 5.5, comma 1.5, comes in, and it still does that because I don't think I loaded this. Did I? I did not. Thought I did, but we'll find out. Now I've loaded it again. Too few arguments. So I have a problem. It says too few arguments. Well, that means something. And so I'm going to go over here again to the right. Now I just checked to see what that was. But here's how I checked to see what it was. I came back over, and what I did is I made a change of some kind. And then I immediately, when I made the change, went over and tried it by loading it. But if I do a check selection here, it tells me there's too few arguments, setVar Oz mode.
So I've got a set var os mode someplace that doesn't have a value assigned to it. So when I do this and double click on it, it comes up here, set var os mode, because I don't want set var here. I made a mistake. That actually is a mistake I was planning on making, but I didn't actually intend to right then, because set var sets a variable and I don't have a value after it. What I really wanted here was not set var. What I really wanted here was get var. I needed to get the value of that variable. So if I come over here now, the value of that variable is 6183. Now when I double click on this and I check it, which I should have done before, checking's done, it looks pretty good. Now we'll try it again. So I'll load that one more time. Come back over here, SSECT, enter, first corner of rectangle, right here, second corner at 5.5, 1.5. Now it comes in and it draws everything the way I want it to because it isn't being overridden by an object snap. So two things here. I made a deal about making a distinction between setQ and setVar. In this case, setVar is not what I wanted. SetVar is what I wanted down here because I'm setting the variable os mode equal to whatever it was. But to find out what it was, I've got to get the variable, not set the variable. Now let's do some more things with this. When I say let's do some more things with this, I'm going to need error trapping in this. But I'm looking at this now and I'm thinking, wouldn't it be nice if I could bring this in at an angle? So if I come back out here, now very seldom, by the way, in architectural am I going to need to put that section symbol at an angle. So this is probably not necessary. But what I'm just doing is showing you how you might continue to improve programs. If I really did have an angle, I probably could just use this program, put it in, and then rotate it. That'd be no problem. But there may be other things that you want to apply where you are putting an angle in. So let's say I want to do an angle on this. Well, in order to do an angle on this, what I want to have to do is to find out from the user what angle they want that to be placed at. And this is where I need RTD, well, radians to degrees is the one I'm going to use. But I need one of these two functions, which means those two functions should really be loaded all the time. I'm going to load them right now just to make sure they're available. And now I'm going to go in, I'm going to make a few changes to this. But first, now that I look at this, I was about to show you what, I've got some code in the book that actually does this by rotating the user coordinate system, then placing, then doing the drawing, and then putting the coordinate system back to what it was. I'll show you what that code would look like. But it just occurs to me, I think I might have a better way to do that. So let's show you what that one is, and then I'm going to show you why I'm going to fix it. I'm going to change it. So anyway, here's the code right here that would go ahead and rotate the user coordinate system. So what it does is this. It asks you to begin with, what is the angle that you want this structural section to be at? So let's say I wanted it to be turned at that angle right here. So then what is the angle, and you have to then convert it between radians and degrees. So here's a case where I've got the RTD function used here. So I'm going to ask you what angle you want. And then it's going to rotate the user coordinate system at that angle. Now, it's going to rotate it around the z-axis. Here's a case where it really is going to require that I have error trapping. I'll show you why. So I'm going to load this one up, just the way it's written. And again, if I hadn't done the conversion here, the angle is not going to come in right. So this is called SSECT2. So that's the one we're going to run. Now, angle of structural section, I'm going to just pick a couple points right here. So that's the angle I want. You notice that the user coordinate system just rotated. Now it asked me for the first point in the rectangle. I'm going to say right here. Then I'm going to go at 1.5, 5.5, and it'll, oh, that's not 5.5. It looks more like, yeah, that's a 2 by 10, so that's 9 1/4. But one thing I could do here is use the stretch command, take that corner and then put it right up here instead, and then I'll have exactly what I need. But let me do that again, and this time it'll be 9 1/4. So again, I'm going to sorry, I don't know, I must have hit the F1 key. SS section 2. once again, I'm going to say the angle, and I'll just pick these 2 points indicating what the angle is. I could type in the angle, but I don't need to. Now the first corner, let's just say we have a double header on this. And then the next one at 1.5 comma 9.25, and doesn't do the right thing. And it doesn't do the right thing because I'm not sure. Let's find out. Let me try it once again. Let me stop hitting that F1. This is, I haven't reprogrammed this yet, but I normally reprogram my F1 key so that it is the escape key. So now it is the escape key. SSECT2. Angle of the structural section goes from here up to here. Oh, I know the problem. And now it does rotate this. Now the first corner is going to be this one. The next corner would be at 1.5 comma 9.25. I press enter, and it doesn't appear to have worked. And the reason it doesn't appear to have worked is because unlike the other one where I took care of Oz mode, I did not take care of it here. So now I'm going to come down and we'll take care of that. And I think that's going to take care of my problem. My intent here is to just show you the development of a program and how you improve it. And that means you do test things and things don't work sometimes. So again, we're going to do a set Q. This time I'm going to do it right. Set Q Oz mode, or OS, and then get var, not set var, Oz mode. Okay, so that'll get us what we want. And if I do that right now, that's going to return 6183. Now again, right down here, I'm going to set var Oz mode equal to 0, and then I'm going to set it right back again down here. I also have the UCS set back again down here. Set var Oz mode OS, because that returns it to what it was. So let's see if that fixes this. Because what it does, it turns off object snapping so that it doesn't snap to the wrong thing, which I think is what was happening over here. We're going to try it again. SSECT2, it's that one. Angle, be the same angle. I could type that in if I knew the angle, but since I don't, I'm doing that. Now the first corner, I'm going to go to object snap right there. At 1.5 comma 9.25 goes right in because I overcame the object snap problem. Now I introduced another problem here. And the other problem that I introduced here is that if I were to cancel halfway down through this, my user coordinate system would be stuck at what it was. Let me show you what I mean. So that's the program I'm running. I say, yeah, I want to go from here to here. And then I change my mind and hit escape. I'm still rotated in the wrong coordinate system. So now as I'm trying to draw, I'm like, what's going on here? You know, it's drawing. Actually, the reason it kind of looks okay, that's a 330 degree angle though. It kind of looks okay because I have 15 set. But suppose I had 90 set. Now, the only angles I get that are tracking are angles in that coordinate system. I need to go to UCS world to come back out of it. This is why error trapping is so valuable. So what I'm going to do on this, and I'm just going to throw in a quick error trapping function here. We looked at that a little bit last time. We'll do it one more time. And error trapping is a separate function just the way that the RTD and DTR are separate functions. Now I'm going to define a new function, and I'm going to define a function called ERRTRP. Well, just okay. Error trap. How's that? SSECT2. In other words, this is the error trapping function specifically for this program. If you want to do something, you have to put something in that little place right there if you want to have a prompt, which is what I want to. So I'm going to put that in there. Now, what's going to happen if something goes wrong with this program? That's what we're really saying. What I want to see happen, well, the best way to do this is to see what is it you return at the end. And if you don't get to the end, what do you want to happen if somebody cancels this? That's what I want to see happen, both of those things. So those are the things I'm going to have happen when an error takes place. But before I can use this, I have to refer to it in my program down here. So we can, that's going to have a closed parenthesis here, but we're not quite done with this. I have two other things I want to add. So before I can use this, I have to have a reference to it down here. Well, there's a special function, special variable, and that special variable is called star error star, and it holds the value of whatever current error trapping function is active. You can only have one active at a time. So I want this one to be active, but it's possible that I have some other error trapping that's already active, and I might want that to stay active. And it might be from another program, or I might have a general one where I say, I'm often using the same variable names, OS and AP for aperture or whatever. I can have just a standard error trap that always returns the values for Oz mode and pick box and aperture or whatever I normally would change in a program. I'll use the same variables for each one, and I'll just change all of those back to whatever they were. So I could have a general one running. The point is, I want to override whatever's there right now, but I don't want to lose it. So I'm going to now set Q. I'm just, going to make it my own variable. I'm going to set equal to, and I'll call this temporary, how about this? Current error trap. That's the name of my variable that I just came up with. I'm going to set it equal to star error star, because that's what AutoLISP uses as a name of whatever the active error trapping function is. I want that to be active, the one I'm creating up here. But first I'm going to find out whatever is currently active, save it, and then when I'm done, now I'm going to say, let's define star error star as this. Now I'm going to highlight that, double click it, copy it, bring it down here and paste it to make sure I don't make any errors. So what I'm saying here first is if there's an error trapping function currently active, I'm going to save what it is to a variable that I invented. Then I'm going to reset the current error trapping function, which is what star error stands for, the current one, equal to that one right there. If something goes wrong, here's what I want to see happen. Set UCS back to the previous user coordinate system, set Oz mode back to OS, and set Q error not equal to this, but equal to that. We're going to reverse these two things. So I'm going to say set Q which is what that should say. I'm going to say set Q error equal to current error trap, so it goes back to what it was when we started. So I'm doing a set Q here. I don't know why I typed in a defun. Set Q here, that's the variable that I came up with to store the current active error trapping function in, and then set Q make current the one that I created. And then the only other thing I want to do is I'm going to put a prompt in here, and the prompt's going to be just a note saying resetting UCS and Oz mode. So my error trap looks like this. I'll load it. Now this has a reference to an error trap. I'll go down through here. First I'll check that, make sure it's okay. Then I'll go back and I'll load that. So here's the difference now. I'm going back into SSECT2. I'll do the same thing with the angle. I'll say the angle is from here to here. You can see it changes the coordinate system. I'm going to press escape. And when I press escape, I get an error message. Oh, this is good. I'd forgotten about this. Now here's the thing. Something went wrong. I look up here and it goes, what went wrong? So we can't invoke command from an error trap without a prior call. And just don't worry about this. That's another internal variable. But it gives me a solution. This is almost never happens in programming. Normally you get an error, but they don't tell you how to fix it. This tells me how to fix it. I need to add a -s up here to the command right there. So when I have a command that's going to return the UCS to the previous one, I need to do that. And it tells me that right here. Now, all right, let's try that again. I'm going to load that again. Now I'm going to come back out here, go back to the user coordinate system being the world coordinate system. This is the fun and the frustration of Lisp programming, by the way, or any programming language. There's all kinds of problems to solve, but sometimes you get a little tired of solving them. In this particular case, though, I'm glad that happened because I'd overlooked that. I'd forgotten about that, that the command function by itself can't be called from an error trap function. So now let's try it and see if I fixed it, because it told me I had a solution. Let's see if it really worked. So I'm going from here to here. Program would normally work just fine. It does that. I change my mind and press escape. Bang. It goes right back and it gives me a little message resetting UCS and Oz mode. So I know that when I did that, everything got set back to what it was. And this is something you should put into every program that you ever write if you change a variable, or in this case, use a coordinate system or something else that should be returned when you're done. Now,